I'm super excited to be talking to all of you today about building for the web. And what a great time to be talking about the web, because as you might have heard, earlier this year we actually celebrated a really big anniversary. That's right, the web turned 10 years old. Tim Berners-Lee shared his vision for the World Wide Web in a March 1989 paper titled Information Management, a Proposal, which his boss at the time heralded as vague, but exciting. He worked on this idea at CERN, and for the next few years, and in '93, we all got to play along with the free Mosaic browser. And it's been a wild ride in the years since. In just the last couple of years, we've gotten to try a bunch of new web browsers, so you can be a webmaster no matter what operating system you use. But first, let's start with the basics. What is the web, and how does it work? A web page is just a normal file. It's a rich text document written in HTML, which contains Tim's hyperlinks that refer to other web pages, which, when clicked, leads to a little bit of magic as your browser finds the actual physical computer also connected to the internet for that website. And on that computer's web server, it translates the requested web page into an actual file stored on its file system. It opens that file and sends it across the internet back to your browser, and this is amazing. But over the last couple of years, we've seen an evolution from serving static files or websites to dynamic programs or web applications. And this has let us make totally new kinds of experiences where the program is being run not on your computer, but on the web server. Web servers have been extended so that if a requested file is in a certain directory, it's a program. Rather than just opening the file, it executes it, and it sends its output back to your browser. And this is so cool, because literally any program can now be a web application. It can be anything from a simple shell script to a complex compiled C++ program. Of course, doing anything other than simple tasks is pretty annoying in a shell script, and C++ takes years to master and about as long to compile. So scripting languages like Perl are great, but they weren't really designed with the web in mind. And here PHP's really taken off. So PHP is a programming language created a few years ago in '95. Now, I say programming language because its creator said he never really intended it to be a programming language, but really, it's the first language built for the web. And PHP feels kind of revolutionary because it's blurred the line between files as web pages and programs as web applications. For instance, this typical HTML file is actually a valid PHP program. Now, this one doesn't do anything interesting yet. It's more page than program, but insert a PHP tag, and now we're in application land. And part of why I like PHP so much is that it's super easy to learn once you know HTML. You can incrementally include dynamic logic into existing HTML files, and it scales up to everything you could do with Perl. I also love that PHP is free and open source. And part of what we're now calling the LAMP stack. It's the first time that all the tools you need to build web applications are free and open. In fact, I predict that the recent excitement around the web and free and open source tools will inspire a future generation to learn to program with PHP. All of which makes me wonder, what's the web going to look like in another 10 or 20 years? I really miss those days. I should introduce myself a bit. So as you heard, my name is Lee. I'm one of the creators of GraphQL and the director of the GraphQL Foundation. And GraphQL itself actually just turned 10 years old this year. So we actually have a ton of fantastic talks in the GraphQL Conf track. We're going to kick it off a little earlier than some of the other tracks, so come by at 1:45. I hope to see many of you there. And no, I'm not actually a time traveler, just occasionally detached from reality. I'm fully aware that the current year is 2022. But it's fun for me to look back on 1999 because that's when I first got involved with the web and taught myself to program by learning PHP. And, you know, building Pokemon fan sites with the LAMP stack. And I'm so grateful for that, since in the following decades, I've watched the web and PHP explode in popularity across the early pillars of LAMP. Wikipedia in 2001, WordPress in 2003, and Facebook in 2004. which is where I spent a decade watching the evolution of PHP, LAMP, and complex web apps. And what's been most fascinating to me is that the programming model and mental model of the web actually kind of feels largely the same as it did back when these tools were first introduced. Of course, at the same time, we've tackled growing complexity, have built far richer experiences, grown our community 1,000-fold, and scaled to billions connected to the web. And I see a pattern behind this progress, a relationship between three kinds of advancements: better and more powerful abstractions, clearer and more expressive syntax, and improved and refined mental models. In fact, I think these three influence each other in a kind of loop. We build better libraries and abstractions, which unlocks new capabilities and better performance. We introduce new programming patterns, APIs, and ultimately new syntax into our languages to better express ourselves in terms of those abstractions. And that creates clarity, which leads us to improve our mental models, how we think about what we build. So today I want to illustrate this process through a couple brief stories I saw unfold at Facebook across three problems we're all really familiar with: rendering views, managing state, and fetching data. And I want to start with rendering views because it was PHP's killer feature. PHP started out as a template language, and it introduced the mental model of a web app as dynamic data interwoven into static HTML. But PHP templates were kind of notoriously difficult to reuse. And then there's security. Naive, simple-looking PHP code usually suffered from critical cross-site scripting vulnerabilities. These in particular were constant thorns in the side of an early Facebook. So to resolve these issues, Facebook built a framework called UI Component. It was heavily inspired by MVC frameworks and the browser's own DOM API. And for example, you might make a button called UI Button Component. And to use it, you just instantiate one. You could call methods to set properties, add children, and add behavior with a kind of DOM-inspired API. Then you just call render, and you get the complete resulting HTML necessary to put that on the screen. This solved UI reusability for us. We had an API designed for modularity and reuse. And importantly, what we're building here is a tree of UI component instances rather than a template stream of concatenated strings. So it means that it's much, much easier to systemically solve security issues by automatically escaping content correctly based on exactly where it appears. And this is all great, right? Well, one huge downside was that every time we refactored something from templates to UI components, we couldn't shake this feeling that the new code was just worse. There's definitely a reason why people prefer to write HTML over directly using DOM APIs. Luckily, meanwhile, there was a skunkworks project underway at Facebook to rewrite the site from scratch in an effort to achieve better performance, shed technical debt, and this was, of course, a terrible idea. Didn't work at all. But it yielded a ton of super interesting new technologies and ideas, one of which was an extension to PHP called XHP. So XHP introduced an XML-like syntax inspired by the ill-fated E4X JavaScript proposal. But unlike E4X, XHP was just simple syntax sugar atop instantiating plain old PHP classes. This was kind of a perfect match for UI components. The implementation details were exactly the same, but the syntax returned to what we loved about templates. We replaced an imperative mutable DOM-style API with more declarative API. So you may or may not have heard of XHP before, but if you haven't, you're probably hearing all this and thinking, right, that's JSX. So you might not know this, but the initial versions of React actually did not include JSX. But as front-end engineers at Facebook first started to use our early versions of React, they immediately were responding with skepticism. Their mental models had already been shifted by XHP, and it wasn't until introducing JSX that React actually started to get adoption within Facebook. And I think this refinement of abstraction, syntax, and mental models continues with post-React UI libraries like Vue and Svelte. These come full circle back to the original compelling idea that any bit of HTML is also a valid component. So early web apps actually used very little JavaScript. The first 15 or so years of the web featured applications with a kind of enviously simple model for managing state. You load a page, you click a thing, which loads another page, maybe you submit a form, which, again, loads another page. And of course, that means that every state transition is a full page load. And in 1999, that happened over a dial-up connection, which was painfully slow and also kind of loud. It also didn't allow for any rich client-side or event-driven apps like chat. Facebook Chat was the first real client-side heavy JavaScript experience on Facebook. But for years, the same bug kept popping up over and over again, the zombie notification. Something on Facebook would light up as if you had a message, and excited, you go click on it only to find no new message for you. In fact, this was one of many. Chat was notoriously buggy. Why? Well, the key problem was that chat appeared in at least 3 different places: messages page, chat bar, and the notification icon in the top corner. Well, chat events could come from a lot of different sources. Without a central source of truth, inconsistencies were just common. So our solution was to rewrite chat with a new architecture. Use the mental model of a simple server-side state, but implemented client-side. So any event that could alter state changed from an event emitter to instead be represented as an action. An action was just a declarative description of what should change. So you can kind of think about this like a post request to a simple PHP server. Of course, after sending a post request, the entire page comes back replaced with its response. And that wouldn't necessarily be better because that's slow, it flickers the UI, and it completely destroys local state, like whatever you happen to be typing at the moment, particularly important for chat. These, of course, were some of the motivating reasons for us to build React. This action-based architecture was called Flux, and together, along with React, provided a much better way to manage state and allowed us to bring the one-way data flow of simple PHP apps of the 90s to the dynamic JavaScript clients of today. Of course, now few of us use Flux as it was presented years ago. We've since again continued through this loop of better abstractions, clearer APIs and syntax, and more refined mental models. We use things like Redux, we have improvements to our languages. We use these ideas, but in new forms. So looking back, I think part of what made LAMP so empowering was just how easy it was to use and create data-driven views. Query your database with SQL, save that result to a variable, and then render a template with the data. But you couldn't really scale that past thousands of users or to large teams of developers or to complex data-rich applications. And of course, Facebook had to do all of those things, especially as they started work on features like Newsfeed. So building Newsfeed led to the dreaded N+1 problem, where many distinct elements on the page each needed to load specific data, leading to many blocking queries, which could be very, very slow. Facebook solved this by building a library called Preparable. So Preparable was just a simple state machine. It focused on loading the specific data necessary for one particular part of the screen, like one specific Newsfeed story. And in a state machine, it would go through steps, and each step would just request some data to be loaded, and then in the next step, that data would be available, and it could continue through as many steps as was necessary for that particular piece of UI. Then, all the preparables on the page were gathered, called in parallel, so that they could send back the next step of data that they need, and it would go out in a single batch request to Memcache. Memcache would come back, populate all the preparables with the data that they needed, continue in the next step, iterate, 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 until everything on the page had all the data that it needed. And this was great. It led to really good performance. We also were able to hold on to that modular maintainable code base that we wanted. All the data fetching needs were located in each particular piece of code. And this really helped us grow and scale. And despite growing complexity, we scaled to millions, then billions of customers with a super complex bit of UI. And actually, this pattern persists at Facebook to this day. And I thought this was super novel and clever. I remember seeing this pattern, and I thought it was amazing until I learned about generator functions. In particular, when I learned about Regenerator. So Regenerator was an early JavaScript transpiler built long before the days of Babel. It transformed specifically generator functions into JavaScript that any browser could run. And this blew my mind. So I thought JavaScript generators looked so different from regular JavaScript that I had no idea that this could even be possible. So of course, I had to learn how it worked, and luckily, that was pretty easy to do. I just wrote a generator function, put it into Regenerator, and looked at what came out the other side. It was preparable. So I learned that a generator function is just clearer syntax for describing a state machine. Exactly the same kind of state machines we were using for preparables. So later enhancements to preparable at Facebook each aligned with generator function syntax. So for nested data, we have yield star. For error handling, we have try catch. For complex control flow, we just have for and while loops. But we actually spotted something even better. C# had just introduced async functions, which was this unholy union of the state machine modeling syntax of generator functions alongside the data fetching abstraction of promises. This felt super promising because not only did we get the state machine, but we also handled this sort of mode of ask for a thing and then don't come back to me until that thing is done. So light bulbs went off, and Facebook again extended the PHP syntax to include async and await, and undertook an effort to update preparables to the easier to understand and far less error-prone async functions. These have caught on. So this further clarified our mental model, and later async functions merged with UI components to create GenXHP. This co-located data fetching and view rendering into one place. So we had encapsulation of complicated data-driven components. This evolution was happening right as we were starting work on GraphQL. And I think you can see the influence of all of this on the syntax and actual execution behavior of GraphQL queries. In fact, we later realized just how important preparables were to GraphQL that we were inspired to create an open source data loader, which solves the same problem for JavaScript. And the resulting mental models from GenXHP and GraphQL inspired us to build Relay. And this feels familiar again, like that simple PHP code, where you asked for what you needed and then rendered what you wanted. So I think LAMP has become so popular in part because PHP provided this really compelling mental model with expressive syntax for building web apps. Well over 20 years later, it feels like in many ways, despite constant evolution, we found ourselves in large part back to that same mental model. And that's thanks to the steady march forward of better, more and powerful abstractions, clear and more expressive syntax, and refinements to that model. And this has helped us build richer, faster, more complex experiences, grow our community of web developers to millions, and connect billions of people to the web. And I don't think we're anywhere close to done. There's still plenty of problems to improve upon that I think could benefit from this exact same progression, maybe again inspired by ideas from decades ago. So reflecting on 30 years of the web, Sir Tim said, "Today, half of the world is online. It's a moment to celebrate just how far we've come, but also an opportunity to reflect on how far we have yet to go." The web is for everyone, and collectively, we hold the power to change it. It won't be easy, but if we dream a little and work a lot, we could get the web that we want. All of which makes me wonder, what will the web look like in 10 or even 20 years from now? I hope to be here to talk about it and look forward to building the future of the web with all of you. So thank you.